Alright, so here's another theoretical yield type problem. Now what would be a theoretical yield if 112.0 litres of H2 formed 80.0 grams of H2O? Now remember, the whole point of this is that we've been given an amount of a reactant. Remember, the reactants are always on this side and the products are always on this side. We're always given an amount of reactant. We're trying to figure out how much of a product we should have gotten. Now 80.0 grams is not the amount of H2O we should have gotten from this. The 80.0 grams represents some sort of usually smaller amount of water than what we should have gotten. And we're going to figure out what that amount should have been. Now we're going to start out with 112.0 litres of H2, and we're going to figure out the number of grams of H2O. Now I know the unit I need from here. We're actually not going to use the 80.0, but the grams of water is going to be very important to us, because if we were to do one more step and get the percent yield, we'd need grams of water so that we could get an intelligent percentage here. If we used litres of water or something else, we'd never be able to divide those two, and we would never be able to get an answer for a percent yield. So we know we need grams of water. We're going to use the flow chart here. We're going to start out with litres of H2, go to moles of H2, go to moles of H2O, and then go to grams of H2O. Alright, so starting out we've got 112.0 litres of H2 times, and then a line. Now we know that litres of H2 will go on the bottom. The first thing we want is moles of H2. The relationship between these two is that 1 mole of H2 will equal 22.414 litres of H2 times, and then a line. We know moles of H2 goes on the bottom, and we know that moles of H2O is going to go on top. That's what we need next, is moles of H2O. The relationship is 1 mole of H2 is equal to 1 mole of H2O times, and then a line. We've got moles of H2O on the bottom, and for the reasons I discussed before, we're going to have grams of H2O on top. It has to match the unit that we've got here for the comparison section. Alright, so it's going to be 18.02 grams of H2O is equal to 1 mole, so that's what the answers are going to be there. And this is going to pop out to be 90.06 grams of H2O. So what this represents is the amount we should have gotten from this reaction. And you can see that if we were to do a percent yield, we'd get it by doing 80.0 grams of H2O over 90.06 grams of H2O, and that would end up giving us our percentage. And the point I want to make here is that this would cancel with this, and we multiply it by 100%, we get a percentage. And we're managing this because those units are the same, so that's highlighting why we know we're after grams of H2O here. So always remember, you're starting with the reactant that's here. It's not always going to be first in the problem either. Sometimes the reactant might be over here, so you're not always just going to be going for the first number in the problem. You're always going for the reactant and then figuring out the amount of product, so you can compare it to this at some later date to figure out a percent yield perhaps. But here we were just after the theoretical yield, which was 90.06 grams of H2O.